Today's show is sponsored by CloudZero. For software-driven companies focused on growing margins, CloudZero is the only cloud cost intelligence platform that puts engineering in control by connecting technical decisions to business results. By analyzing cloud services like AWS and Snowflake, CloudZero provides real-time cost insights that help you maximize margins. Engineering teams can answer critical questions like, who are my most expensive customers? How much does this specific feature cost our business? What's the cost impact of re-architecting this application? With cost anomaly alerts via Slack, product-specific data views, and granular engineering context that makes it easy to investigate any cost, CloudZero is your complete cloud cost intelligence platform, connecting the dots between high-level trends and individual line items. Join companies like Drift, Rapid7, and SeatGeek by visiting cloudzero.com/cloudcast to get started today. That's cloudzero.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And this is Aaron this week for Cloud News. And as I hit record on this, it is AWS reInvent week, which means a slew of announcements, lots and lots of things that make the keynotes, don't make the keynotes. And we're not going to talk about it this week. We're going to talk about it in depth next week. So we're going to take everything in, analyze it a little bit, and come back to everyone next week with that. But if you go look at Cloud News of the Week, the first article is a link to AWS reInvent and all of the announcements. And it includes the offstage announcements, which that alone is like 5 or 6 pages. The Monday night, the Tuesday keynote with Adam, and kind of goes on throughout the entire week. As I hit record on this, it was not fully populated yet, and they will be populating this site, of course, as the keynotes happen and as the announcements come out. So if that is interesting to you, definitely go check that one out, and you can kind of catch the news along with everyone else. And moving on to article number 2 is actually from Kubescape by Armo. And Ben Hirschberg, CTO and co-founder over there, put out a report about Kubernetes vulnerabilities and takeaways from that. A really interesting article about numerous things. First of all, as Kubernetes has grown, of course, the vulnerabilities are going to grow. That only makes sense. And break them down from there. You've got your typical, hey, something is misconfigured, or something could be just an exploitation of a vulnerability in code. And it goes through each of the types. What kind of vulnerabilities are there? There's denial of service, privilege escalation, et cetera, et cetera. And it's pretty standard across the industry. I mean, this is basically how the vulnerabilities happen. But then it goes into detail of the biggest vulnerabilities specific to Kubernetes for this year and how you can prevent them as well. Interesting article to read and goes in quite a bit of depth, actually, around all of it. And lastly, I'm going to move on to our third article. A third article, actually, this is something I just found it was really interesting. And I know we talked about KubeCon, and we talked about, in particular, the number of booths and the number of sponsors there. And the folks over at Uptime, uptime.build, put together a report. And this is all of the booths at KubeCon, all 290 of them, and the trends related to all of them. Take a lot of time to put some in-depth analysis into this. First of all, what are the keywords on the booths, and made a word cloud around all of that, as well as a graph of the keywords that were used. And actually, I'll say this, one of them was cost. We talked about cost a lot, but actually cost wasn't mentioned, it turns out, all that much. So that was maybe a bit of confirmation bias, at least in my head. But another one was, we said serverless wasn't really seen much. Well, it was only mentioned on 3 booths out of the 290. So it's really nice to kind of get some takeaways from there of some things we were right on and some things maybe we were off just a little bit on as well. It also goes into social media buzz around them, as well as some rankings of booths and some of the creativity around them. Overall, like I said, interesting read, especially if you follow along in the industry and you either followed the event or were at the event as well. So with that, going to finish up cloud news for this week. And coming up after the break, we're going to be talking about building vector search applications.
Today's show is brought to you by Datalore, a collaborative data science platform from JetBrains. Datalore brings together a first-class coding experience for data scientists using Python, SQL, R, and Scala in Juniper notebooks, a modern BI with interactive data apps and easy ways to share your insights with stakeholders, and a live team collaboration on notebooks and no-code automations. You can install Datalore with Docker or Kubernetes in your private cloud or on-premises and be sure that your data doesn't leave your environment. Datalore is free for teams of up to 4 people. Start for free at datalore.team/cloudcast and use the code CLOUDCAST for a 5% purchase discount. That's datalore.team/cloudcast. Buffering. How annoying. Did you know that 17 out of 20 people stop watching a video because of stalling and rebuffering? Don't let your users click away to a competitor's site. If your business lies in online media, rely on CDN77 to deliver a seamless online experience to your audience. CDN77 is one of the leading global providers of content delivery network services. They power the world's most popular websites and apps, such as Udemy, ESL Gaming, live sports TV, and social media platforms. Aside from their massive and redundant global network, you're going to love their no BS attitude and skilled team of engineers ready to help 24/7. No chatbots, no tickets bouncing around unresolved for days, just people who know your use case and can immediately help you pinpoint and fix the problems. Don't wait until your users run out of patience. Go to cdn77.com/cloudcast and ask for a free trial with no duration or traffic limits. That's cdn77.com/cloudcast. And we're back. And folks, as you know, if you've listened to the show for any period of time, you know there's a couple of things we always love. We love talking to new and emerging companies, and we also love digging in when either their founder has done some amazing things in the past, or they're just innovating in a space that is going to become more and more relevant in what you're doing day to day. And today we get to check all those boxes. And so really excited today. We're going to dig into kind of some of the new things that are happening around search and around how kind of the intersection of search and AI and ML are coming together to hopefully give us, better user experiences, help us find information better. And ultimately, how are these things being embedded into applications such that, again, we're creating better user experiences, better ways to find data and interact with the things that are out there. And so really excited today to have Edo Liberty, who is founder and CEO of Pinecone. Edo, welcome to the show. Great to have you on.
Great to be here, man.
You have a really interesting background prior to Pinecone that I want to dig into a little bit. So give us a little bit of your background for those folks that may not be familiar with your work, and then also what led you to go to start the company to get into this space.
Sure. Just as a quick narrative, a chronological run through of my career, I did my undergraduate in physics and computer science, my PhD in computer science, and my postdoc in applied math. I was then an adjunct professor and a director at Yahoo for a while, and then moved into AWS and built a bunch of, started an organization called Amazon AI Labs with a small team, grew up to be a few thousand people, built products like SageMaker and others, which are the machine learning offerings out of AWS. And 3.5 years ago, roughly, started Pinecone, which builds a vector database, which I'm sure we'll talk a lot about soon.
Yeah, no, it's the work that you and the team did on SageMaker was, it's always one of those things that's really impressive when you can take something that obviously in the background is incredibly complicated, and the marketplace goes, boy, that makes things really easy. It's easy to adopt, it's easy to use, and so we're always fascinated when I guess that sort of science meets magic comes together. So We're not going to spend a lot of time on that. Folks obviously are familiar with that work. I want to talk, before we dive into the product and some of the technology behind it. We're all familiar with search. Obviously, you guys are part of the application of search and how you build things around that. But kind of beyond what we all know with things like Google search or Yahoo search or Bing search, like what are some of the more advanced things that are impacting applications where search is a part of that, or even maybe where we don't even see search in the sort of normal way that we think about it? What are some of those areas in which you guys are focused around that are maybe a little more advanced than just the normal, like either text or verbal search we're used to every day?
Yeah, exactly. I think you nailed it. This is, and maybe this goes back to why I even started Pinecone. Working on stuff like SageMaker and so on. It really like distilled for me that there are two very different kinds of machine learning problems. One of them has to do with models and hosting them and applying them and so on. And we have a lot of infrastructure to do that already today.
Yep.
A very different kind of set of machine learning problems has to do with, you can call it search, but it's much more general than that. It's the problem of selecting a small set of items from a very large collection of other bigger set of items.
Yep.
And you choose those based on relevance or importance or, whatever like utility your application has for you. And so this could be anomaly detection. You might have billions of events in your security logs, and you might want to find, the 10 most relevant for some event you're going through, right? That's a search problem, right? That's not text search. It's something very different.
Yep.
If you're a social network and you have uploads of images and you want to make sure that some scammer is not, just uploading images of good-looking people and try to scam people, you want to find that those images don't already exist in your data bank, right? That's a similarity search. That's an image, deduplication problem. That's search, right?
Yep.
If you're recommending items for shopping for customers, you are sub-selecting a very small set of items from your catalog. That's search. And so if you want to power all of these things, and by the way, also text search, if you want to power those things with very advanced computer vision, very advanced NLP, very advanced recommendation engines, that means putting everything on kind of the new stack of AI and deep learning works for representing the data and doing the retrieval and the management of that kind of side of a stack with something like Pinecone, and not like something, I don't know, like a data lake or like an SQL database or like a keyword-based search engine or something, which are woefully inadequate. But it's just not the right thing for it.
Right.
Does that make sense?
Yeah, no, it makes a ton of sense. And it's always the thing, anytime we get a chance to talk to folks who are in the, I'll call it quote unquote database space, one of the first things that we kind of have to do is go like, look, there are lots of ways to store data, but then there's a lot of ways to sort of associate it, depending on what you're trying to do. Certain databases are very good for certain things. They could be, time series databases. They could just be, sort of SQL relational databases. But then there are some unique cases, especially where where you're focused, where either the scale of it or, kind of the relation of how things are, what types of queries you have, you really do need something really, really different. So yeah, I think we've learned that over time. We're always sort of trying to educate ourselves more and more on, what makes the need for kind of a unique way of structuring data, querying data, relating things together, above and beyond that. So it's interesting to sort of hear the types of use cases.
And I think again, you explained it extremely well, which is, at the end of the day, all databases do something fairly simple. They retrieve or summarize some very small subset of data out of a very large collection of items that you have.
Right.
there are, by and large, databases only differ on, or I should say, types of databases, not like specific pieces of software. Like categories of databases differ on what is the kind of objects that you store and how you specify what you want to look at. How do you specify the queries, right?
Yep.
And you can think about graph databases, relational databases, or key value stores, or keyword search, solutions like Elastic and so on. And vector databases are a completely different breed, right? They take numerical representations of objects, of what I would call complex items and no complex data, which we can dive into what that means. And the queries you run on them are numeric queries of similarity, of alignment, of closeness in high dimensional space, and so on, which sound very abstract if you're not used to it. But if you're a data scientist or machine learning engineer, that is exactly the kind of lingua franca that you're used to using in your day-to-day work.
Yeah. I'm inclined to sort of say, how, where does Pinecone fit in this? But I feel like maybe the question to ask before that is, can you explain in some reasonable way? Obviously, you can do it in incredible depth, but like, you said like, hey, if you're a data scientist, this is sort of the normal way you think about things. Like, can you kind of walk through what that might look like in terms of why a vector database makes sense for, kind of what they're trying to do, the way information, objects, things are organized, like kind of give us the sense of like what vector does that's different and why it's really applicable for a certain kind of problems that those folks are solving.
So let's just start by saying what kind of objects we care about, okay? And so the very raw API with somebody coming into Pinecone would look at, like, you'd need to provide what's called vectors. These are numeric representations of items, right? Which sounds very abstract. And you ask yourself, what the hell is this thing, right? I want to say that since the creation of databases or whatever, since for a long time, I've been in this game for a while, right? We have wanted to use databases and data management systems to manage everything, not just rows in a schematized table or like accounting or whatnot. We wanted to deal with images and free text and, JIRA tickets and legal documents and, like everything all the data that we have that is complex. I mean, people call it sometimes unstructured. I think that's very misleading. It's not unstructured. It's very structured. Go tell a lawyer that the legal document is unstructured, right? They're very structured. It's just very complicated. It's not like a JSON. It's a complicated object, right? Now, we as a society wanted to organize them, search over them, label them, figure out how to, manage them and so on. And by and large, it was completely impossible, right? Like the way that we have done it as a society over the last 20, 30 years was to tag things and label them and kind of make those very complex objects fit into something that looks like a schematized table so that we can put them in a relational database, right? That has asymptoted. I mean, it has some value, right? But that in some sense kind of ran the course, and it's like we don't know how to make it any better than it is today. And if you've used any of those systems, that's pretty disappointing. It's not a great place to end up in.
Yeah.
Like as a society, we hoped to be able to do better, right?
Right.
Then comes the deep learning, machine learning revolution, right? That says, wait a second, I don't need to like structurize stuff, right? I can process them with deep learning models, right? That grok the meaning of like an image or a sentence without me having to extract, exactly what the topic is and what the sentiment is and all that stuff. It does it for me because I've trained it on, I don't know how many billions of text documents, right? And now this can take a sentence in English, for example, and represent the meaning of it with this numeric array, with this vector. Now, I, as a human, that looks to me like whatever, like an array of 700 floating point numbers. It just looks like gunk. You have no idea what this means. I mean, this looks very opaque, right?
Yeah.
But for a deep learning model, that's exactly what they want to be looking at. That means everything to them. So let me give an example. If you have a translation model, so a language translation, you translate from French to Chinese.
Yep.
Okay. You take the French sentence, that sentence in French, you break it up to to words and subsequences of the words, right? And then you propagate, you create like a numeric representation of that, and then it's processed in layers of the deep net, right? And at some point it reaches, like, think about it like an hourglass, right? I mean, you kind of process going in, it's like an encoder, and then you have a decoder, something that takes that some layer in the neural net, takes the values in that layer, and then propagates up in a decoder way to generate a Chinese, right?
Yep.
So now what does that layer in the middle, that set of numbers, what does it contain, right? Well, if you look at the numbers themselves, nothing, right? For a human, I mean, this is just a bunch of numbers,
right?
But clearly they contain the information, because you can take those numbers and generate a sentence in Chinese, that means the same thing as the original sentence in French. So clearly it contains the essence of the sentence, the meaning, right? Clearly without caring at all about the specific words, because of course none of the words are going to be common between the two sentences, right? And so we know how to do that for language. We know how to do that now also for images and for audio and for text in general, for more complex objects like I said, resumes or legal documents or shopping items and all that stuff. And the most amazing thing is, because we use deep learning for all of them, this like intermediate representation of all of them is this unified object that's called a vector. And that's what I mean when I say, as a deep learning person or machine learning person, you're used to that, because that's the language all your data is represented in.
Right. Yeah. It seems like, if I'm trying to make sense of this, from a non-data scientist perspective, it feels like if I'm somebody who's using more of what I would call kind of a traditional database, in which you're saying, like, look, for a given amount of time, give me all the sales for North America, between these dates. And, like you can create some things where you go like, with, given a bunch of parameters that, by themselves are all kind of, put together in a certain way, you can get back numbers, you can get back blocks of numbers and summarizations. But the stuff that you guys focus on is much more like, I'm almost asking open-ended questions, or I'm asking things in which, the context of what the query looks like, what the question looks like, is going to change the way that you'd look at the numbers, you'd look at the data, you'd look at how you'd represent it. And in order to do that, you can't just kind of ask these sort of straightforward questions. You have to ask things that have context, that have sort of some open-endedness, that need to be resolved in order for them to make sense. And I think what you're saying is, like, in order to get to those things, you can't store the information in the same way, because it has to be manipulated in all these sort of different angles and different ways and stuff like that. Is that at all sort of in the ballpark of kind of where you're working on things?
Yes, but I think it's much more. It's very concrete. I mean, it's what you're saying sounds, at least to me, almost aspirational. Whereas with Pinecone, like, this is what we're, our service is very well understood and very kind of straightforward for the practitioners who use it.
Yeah.
You're absolutely right. The questions could be a lot more general. For example, given an image, find, other images in my database that are similar.
Right.
Okay. What does similar mean, right? Contain similar objects, have the same, color palette, like, similarity can mean different things, right?
Right. Show me all the pictures of happy dogs.
Yes, exactly.
What does that mean?
Show me pictures of happy dogs. We have a company that built a face detection for cows for managing cattle on Pinecone. We have people who build document search on, where they want to say, hey, give me sentences that mean roughly this. I don't care what words are in the sentence or not, but we have Gong is a big customer of ours. They record
Right.
sales calls and analyze them and so on. And when you analyze it as a VP sales, you want to say, give me every time, show me every time that one of my customers, like, I don't know, asked for a discount, right?
Yeah.
That's a complicated thing, because it's a conversation. You don't know. It's like somebody could say, can I have a discount? But that's very, uncommon.
Right. Yeah. You might be going like, yeah. And you might be saying like, well, maybe it's like, did the tone of their voice, their conversation get negative? Okay. Well, maybe that's that. Maybe did they start pausing more and more when you were talking about pricing? Okay. That might be it. It might.
Exactly. It could be very complicated. Or somebody would say, oh, how much would it be for us?
Right.
It's like, yeah, you can infer that they're talking about price. You can infer that they want a discount, whatever, but there's no specific word that you can look for in that sentence. They're all like word. Just that sequence of phrasing makes it about pricing,
right.
And the context,
Yeah. So
that kind of search is possible if you encode the sentences using machine learning models, again, which are readily available, by the way. Most people don't train them themselves. They just download some pre-trained model from Google or from OpenAI or Cohere or Hugging Face, and they translate them to vectors, and they use Pinecone to search over them, and they are usually pretty surprised that it actually works out of the box.
Yeah. So let's do this. We spent a while sort of talking about conceptual something. So walk us through what Pinecone provides for a customer like Gong or any of your, any of your customers, clients, developers. What part of the things of sort of solving that problem, where does your platform sort of stop and start? And then where does a typical application developer, have to start thinking about what's their part of the job?
Yeah. So in general, you have a few different components in any problem, any solution that would use vector search or a vector database. Okay. You'd have the application layer that manages the objects and the relations and the interface with the customer. You'd have some model that converts your objects, be them text or images or whatever, to these vectors. And you have the vector database that stores them, searches over them, and manages them, right? So you can like add, delete, search, and, attach metadata and so on, right? We are just that. We're just a vector database, right? We're not opinionated on what models you're using. We actually don't even know if your application is an audio thing or a image search or a question answering or a bot, management system. We don't know. Like our system is unopinionated and actually doesn't have any visibility into like what the original application is. That is vended to you as a service, like in the same way that you would use a DynamoDB or Spanner or S3. It's a cloud managed service, and then you build on top of that. So your application's backend would usually work with some MLOps layer to do the machine learning transformations, and we use a vector database for storage and retrieval of relevant results, and the front end will be serving and interacting with your customers.
Gotcha.
Does that make sense?
Yeah, no, absolutely. Yeah. Having, in previous lives, you've seen what it takes to build these types of systems. And, so if somebody, you guys provide Pinecone as a fully managed service, so everything's sort of taken care of. What does the complexity of what you guys build look like? If because a lot of times you get people who go, well, we could build that. We could go grab whatever's in open source, or we could try and build. Yeah. Like, give me a sense of like the things that you take out of the toil that you take away from people in terms of what they would have to do to have something similar.
Yeah. So our very best and most loyal customers are those who actually try to use open source. And the farther they got into that journey, the more conviction they have when they come to us, right? There is an unbelievable amount of work that we put into this on the core libraries, just the vector search itself. They're open source tools. Our solutions are 5 to 10x faster and built like databases. They're not built like science experiments or benchmarking tools, right? Which is roughly what's out there. No disrespect. Some of those libraries are amazing, but they're not built like cores of databases. On top of that, there is orchestration and scaling of this entire thing, running a multi-tenant service, squeezing out costs and low utilization from everywhere and so on. And then there's a whole level of security, billing, monitoring, and so on, alerting when something goes on, fault tolerance, high availability. There's so much that goes into it. And and I'm not even talking about stuff like service, when like something happens, somebody has to wake up in the middle of the night and go fix it, right? When it's Pinecone, that's us, right? When it's not Pinecone, that's you. And the scary thing about vector search and these kinds of offerings is that they're actually very complicated at the core of them, and it's kind of hard to reason about how they work. And so if your team is not really into this, when you have an outage, oftentimes you don't know what to do. So except for scorched earth, just delete everything and, spin up the cluster from scratch and hope for the best. Right.
Yeah, it's not something you want to make a hobby of necessarily.
Yeah, I mean, yeah, exactly. It's not a great practice and not something that not somebody that anybody enjoys doing, And I've been, I mean, a lot of your listeners have been in the hot seat where something awful broke and they didn't know, they didn't write, they have to go fix it, and they have no idea what to do, and it's not a fun place to be in.
Right. No, absolutely. It's it's like Werner Vogels has always said, right? Like there's a whole lot of, undifferentiated heavy lifting underneath what's important to your business. Somebody has to do that. And you want to work with people that gets them up every day. That's what they want to work on. They're experts in it. That's, they've made a business of doing that. Yeah.
So, I mean, people have to pick on something that like customers don't even see. Like we spend, I don't know how many thousands of engineering hours on just our monitoring service, and just us being able to monitor queries for every user, for every region, for everything, and figure out, there is a 20% degradation in latency for some index in some region, and we have to go figure out what's happening there, right? Yep. Just that system alone, many thousands of engineering hours on that, and our customers don't even know it exists.
Right. Absolutely. Well, good. This is helpful. And I meant to ask you about a bunch of the examples. I know we talked about some of them. We talked about Gong. What are some of the other things actual customers are doing that people may have some visibility of, but had no idea how it was happening behind the scenes?
So roughly a third of our applications are search on text related things, and I would say text in a very broad sense, because resumes and reviews and Slack messages and emails and tweets are all text,
sure,
right? But they mean different things, and you wanted the different things with them, right? And so I would categorize as text. That's very common. Roughly a third is our security-based applications. So looking at attack vectors, looking at patterns, looking at all sorts of nefarious behavior.
Right, I can imagine fraud, fintech,
payment fraud, you name it. Okay, so the whole both the analytics side of it and the real-time threat detection in in many systems, both in IT and financials is pretty common. And then there's yet another third of just just you name it, like face detection for cows. It's a very long tail of very creative applications that people built on vector search as a fundamental building block.
Yeah. I so something in me, having my father was a farmer. Somewhere along the line, I would love to sort of know the story of how it got to a point where, because I know farming is a much more commercial thing and heavily technology, but I would love at some point that somebody figured out, like, I can look at what the faces of my cows look like, and I can determine something, how much they're going to milk, how much they have to get fed. But
yeah,
I would love to know the origin of that, how that
so I don't know
technology got connected to that.
Yeah, I don't know that is, so frankly, I'm not an expert in either farming. Or, like, I know so little about this space. I know about the infrastructure side of it, but my understanding is that the farmers know their cows in the same way that, like, if your dogs,
mothers know their babies or something. Yeah,
exactly. I mean, if you have 10 dogs, you know them all. It's like
right.
they're not just dogs. They're like you know who they are, right? And apparently that's again, I know nothing about farming, so if I'm offending somebody deeply, I don't mean to do that. It's it lets you can just detect, this this is this is this specific individual, and like they haven't been out to the pasture for a day, and you maybe should go look at them or something like that. It's right. It's more like that than somehow I think discerning something deep about their well-being from their face, if I understand correctly.
Yeah. No, it's I'm always interested in the use cases that sort of feel like they go off the beaten path a little bit. So good. Listen, we've talked about a bunch. You and I talked before we started. This is probably something that would make for great whiteboards and great demonstrations and code reviews. And if people want to dig into this with you guys, because obviously you have a bunch of expertise in this space that could be relevant to a number of things. What's the best way to engage with you, engage with the Pinecone team, get started in the platform, all that kind of stuff?
So we are engineers ourselves, and we built Pinecone to be consumed by other engineers the way that we want to consume services. So there's a free tier that requires nothing from you except for saying that you're willing to use the free tier, right? And it's free forever, and it's actually pretty generous. You can search and you can use a few million items with all the features and all the APIs. It's all open. You need to start paying when you start scaling the applications, when you go to production.
Yep.
There are like hundreds of examples and tutorials and all sorts of demos online, all free to use, all in like Jupyter notebooks or other types of tools. Just go to the Pinecone.io website and start poking around, and it should be pretty easy to get started.
Yeah, no, that's fantastic.
You can always write to us. I mean, we can always if somebody wants, if they have a specific big application, they're not sure if this is the right fit or how pricing would work, or whether they can get help of some sort or another. Again, there's like easy ways to get in touch with us on the website. Just fill up a contact us form, and we'll get back to you very quickly.
Excellent. Yeah, no, it's always great when people have built it and sort of have some skin in the game in terms of going like, this is how we'd want to use it. We've built similar things in the past, and no, it's great that it's available for free. There's lots of demos and examples and all that sort of stuff to get started. So very cool. Well, listen, thank you so much for the time today. I think we've learned a lot. There's obviously, we're just scratching the surface, but it was a space that we thought was very interesting and has a bunch of applicability that, as we interact with different stuff becomes much more valuable. So thank you so much for the time. Really, really appreciate it. Good to learn this. Folks, with that, I'm going to wrap it up. I want to thank Edo for his time. Dig into this. If you're in this space, if your company's in this space, these guys obviously have a ton of expertise in it. So with that, I'm going to wrap it up. I want to thank you all for listening. Thanks for telling a friend. Thanks for helping us grow the community, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.